Before you hear anything else about this video, pause for 1 second and think about what is inside your skull right now. Not your thoughts, not your memories, the actual organ, floating in fluid, suspended, dependent on gravity to function the way it has for every second of your entire life. Now imagine removing that gravity completely. On April 10th, 2026, four astronauts splashed down off the coast of San Diego and were pulled out of the ocean looking like heroes. And they are heroes. Nobody is taking that away from them. But within hours of that capsule hitting the water, a small group of NASA flight surgeons began quietly doing something the press conference cameras never showed you. They started comparing brain scans. Because what happened inside the skulls of Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen during those 10 days in deep space is not something that gets mentioned at the welcome home ceremony. It does not fit on a banner. It does not make for a good speech. But it is happening, slowly, measurably, and in some cases, permanently. This is what nobody is telling you about what the Artemis II mission actually did to the 4 human brains that made it around the moon and came back. Here is the first thing you need to understand. Your brain does not sit still inside your head. It floats. It sits suspended in cerebrospinal fluid, a clear liquid that surrounds it, protects it from impact, delivers nutrients, and flushes out waste. Every single day of your life, gravity is doing quiet, invisible work on that system. It pulls blood and fluid downward. Your heart pumps relentlessly uphill against it just to keep your brain supplied. Your body has been doing this without interruption for your entire existence. It took evolution roughly 4 billion years to build that arrangement. The Space Launch System dismantled it in about 8 minutes. The moment that rocket cleared the launch pad on April 1st and the Artemis II crew reached orbital velocity, the gravitational rules that govern every fluid in the human body simply stopped applying. There was no more down, no more pulling. Astronauts have a nickname for what happens next. They call it puffy face. Chicken legs. The face swells. The legs thin out. Anyone who has seen photographs on the International Space Station has seen this effect in the crew's faces and never quite understood what they were looking at. What they were looking at is the body being redistributed. And that redistribution does not stop at the jawline. The fluid keeps moving upward, into the neck, into the skull, into a closed, rigid space where there is absolutely nowhere for the extra volume to go. And when fluid enters a closed space with no exit, it does not politely wait. It pushes, it shifts things. It rearranges the structures that have spent your entire life sitting exactly where they belong. Within hours of reaching orbit, the brain begins to drift upward inside the cranium. A landmark 2017 study published in the New England Journal of Medicine examined 34 astronauts and found exactly this: upward brain displacement, narrowing of the central sulcus, the deep groove that divides the front and back halves of the brain. By the end of the long mission on the space station, MRI images have documented the brain physically displaced toward the top of the skull, pressing against bone, compressing the channels where cerebrospinal fluid is supposed to flow freely. That is the honest objection, and it deserves an honest answer. The fluid-filled chambers inside the brain, called ventricles, expand during extended spaceflight. A 2023 study tracked 30 astronauts and found that after 6-month missions, ventricle volume increased by more than 3/4 of a milliliter. That number sounds small. The follow-up finding does not. Those ventricles took approximately 3 years to return to anything resembling their original size. 3 years of recovery. For a 6-month flight, for a 10-day mission, the effects should be smaller. Almost certainly are. But here is what makes Artemis II different from every mission that came before it. Only 24 humans have ever traveled beyond Earth orbit. The last of them returned home in 1972, before MRI technology existed, before diffusion imaging existed, before anyone had the tools to look inside a returning astronaut's skull and measure what changed. Wiseman, Glover, Koch, and Hansen are the first human beings in history whose brains have been scanned before and after a journey beyond the moon's far side. Whatever those scans reveal, science has never seen it in a human being before. We are in entirely new territory. Now add the second problem on top of the first. The International Space Station sits inside Earth's magnetic field. A weakened and imperfect field at that altitude, but a field nonetheless. It deflects a significant portion of the high-energy particles streaming in from the sun and from the far reaches of the galaxy. The Artemis II crew flew past it entirely, beyond the Van Allen belts, beyond the magnetosphere's reach. They entered the full radiation environment of deep space for the first time any human being had done so in more than 50 years. Galactic cosmic rays, solar particle events, high-energy protons and heavy ions that do not slow down for spacecraft walls and do not negotiate with human tissue. Orion's shielding reduces the exposure. It does not eliminate it. A single heavy ion passing through a neuron is capable of breaking DNA strands, damaging cellular infrastructure, and in controlled animal studies have produced measurable deficits in memory, learning ability, and emotional regulation. Over 10 days beyond Earth's magnetic protection, a small but statistically real number of neurons were struck. What that means for 4 specific individuals will not be known for months, possibly years. Now add the third. When fluid accumulates inside the skull and has no gravitational mechanism to drain, intracranial pressure rises, not catastrophically at first, subtly, chronically, day after day. Approximately 70% of astronauts who spend extended time in microgravity develop a condition called spaceflight-associated neuroocular syndrome, SANS. The back of the eyeball flattens. The optic nerve swells. The retina develops folds like a sheet of paper crumpled at the edges. Astronauts return from missions nearsighted. Some need reading glasses they never needed before. Some have had choroidal folds that were still visible 7 years after their mission ended. Think about what that means. A person climbs into a spacecraft with healthy, normal vision, spends time in orbit, and comes home with an eyeball that is permanently shaped differently than the one they launch with. This is not a rare outcome in long-duration astronauts. It is the most common one. For a 10-day mission, the severity is expected to be lower, but the same underlying mechanism was at work inside every one of the Artemis II crew members from the moment they reached orbit. What makes the Artemis II data uniquely complicated is that 3 of the 4 crew members have been through versions of this before. These are not first-time flyers. Their neurological systems have already accumulated exposure that the medical community is still analyzing. Christina Koch spent 328 consecutive days on the International Space Station in 2019 and 2020, the longest single spaceflight by a woman in history. Victor Glover spent 168 days on the station as pilot of SpaceX Crew 1. Reid Wiseman logged 165 days on Expedition 41 in 2014. Then they flew to the moon. When NASA talked about post-flight medical evaluations, that is a polite phrase for we need to scan these people and compare the scans to everything they had before, because we genuinely don't know what the combined effect is going to be. For most of that distance, they were in a tin can the size of a large SUV. For adults, 1 spacecraft, no real daylight cycle, no horizon, no gravity. Every few seconds, another cosmic ray passing silently through the cabin and through them. The human brain was never meant to process that environment. Some of what it does to process, it does not reverse the moment you splash down in the Pacific. Astronauts who have come back from long missions report something they call space fog, difficulty concentrating for the first week, mild coordination problems, words that don't come to the tongue as fast as they used to. The twin study compared Scott Kelly's year in space with his Earthbound twin brother Mark, and documented measurable decrements in cognitive performance that persisted for months after Scott returned. Commander Wiseman walked off the recovery ship under his own power. His brain had to argue with itself the whole way. The vestibular system, the inner ear balance network that tells the brain which direction is up. In microgravity, the brain receives no reliable gravitational signal from the inner ear, so it does what it always does. It adapts. The brain stops trusting those signals and leans harder on vision and body position sense to figure out where the body is in space. This is a useful adaptation in orbit. On Earth, it is immediately destabilizing. The crew of Artemis II hit that wall the moment their capsule struck the water at 8:07 p.m. Eastern on April 10th. Walk too fast. Try to stand up like a normal human, and the spinning starts. Commander Wiseman walked off the ship. His brain was arguing with itself the entire way. Structural MRI studies conducted on dozens of astronauts have documented something that researchers are still working to fully interpret. Regional gray matter volume changes after spaceflight, increases at the top of the brain, decreases near the base. Some of these differences persist well beyond return to Earth. The glymphatic system, the brain's internal cleaning network. While you sleep, cerebrospinal fluid flushes through microscopic channels surrounding the brain's blood vessels, carrying away metabolic waste products, including proteins that accumulate over time and are linked to neurodegenerative disease. Extended spaceflight enlarges these channels. The enlargement persists after return to Earth. What that means for the long-term neurological health of people who spend significant time off-planet, whether it represents some form of accelerated biological aging, is a question that current science cannot yet answer. Christina Koch, a brain that has already experienced nearly a year of microgravity effects, then went further from Earth than any woman has ever been. When the next MRI scan comes out, it will be one of the most unusual neurological data sets in human history. None of this diminishes what the Artemis II crew achieved. Reid Wiseman carried the memory of his late wife Carol through that mission with such dedication that the crew named a lunar crater after her. Victor Glover became the first black astronaut to orbit the moon. Jeremy Hansen became the first non-American. Christina Koch became the first woman. What they did matters enormously. What their bodies experienced while they were doing it also matters enormously. Every time a human being leaves Earth's magnetic field, they age a little faster in ways we're only starting to understand. NASA rarely speaks about this openly in press conferences, not because of a cover-up. There is no conspiracy. The data is public. It is in journals anyone can read. Over the coming months, each of the 4 crew members will undergo repeated imaging, cognitive assessments, vision evaluations, and balance tests. That data flows directly into planning for Artemis III, the first crewed lunar landing since 1972, currently targeting 2028. And beyond that, it feeds into the largest unanswered question in human spaceflight right now. Can we send people to Mars without permanently changing them? A round trip to Mars takes 2 to 3 years, most of it spent beyond Earth's magnetic field. Every neurological effect we have discussed today, scaled up dramatically on a timeline that makes 10 days look like an afternoon. On Mars, there is no early return. The orbital geometry does not allow it. If something goes wrong neurologically 8 months into the mission, the crew lives with it for another 1.5 years before seeing Earth again. The crew didn't just travel around the moon. They delivered their brains as test data. Every measurement taken on them between now and the end of 2026 will help shape whether the next generation of human explorers comes home the same people they left as. The real Artemis II is still unfolding slowly inside 4 Skulls, inside the quiet imaging rooms at Johnson Space Center, where a radiologist is right now comparing a before scan to an after scan. A piece of space came back with them, tucked inside the architecture of their own heads. And it is going to take years to find out exactly what it did there.